A uniform electric field E exists along the positive x-axis. Okay. The work done in moving a charge 0.5 coulomb through a distance 2 meter along a direction making an angle 60 degree in x-axis is 10 joules. Okay. The magnitude of electric field is, okay, this is your first question. So what are they have said in this question? They have just said simple things. What? First of all, they have said there is a uniform electric field along the positive x-axis. There is a uniform electric field along the positive x-axis. This is uniform electric field along the positive x-axis. What? X-axis, positive. Okay. This is what they have said. And what they have taken, the work done in moving a charge 0.5, okay, through a distance 2 meter along the direction making a 60 degree angle. Okay. Now they have said take a charge of 0.5 coulomb. Okay, they have said take a charge of 0.5 coulomb and move that charge how much distance? 2 meters. Move that charge 2 meters. In which direction? 60 degree to this direction. What they have said, take a charge and move that charge 2 meter 60 degree to this charge. How? Like this. 60 degree. 60 degree. What we are meaning? This is a charge. 2 meters we are moving 2 meters. And 0.5 coulomb. Okay. And the work done from moving a charge from 0 to 2 meters is, they have given, the work done is 10 joules. So in this case they have described all the things. Now they have said you to calculate the magnitude of electric field. You need to calculate the magnitude of electric field. How you can calculate the magnitude of electric field? You just know the formula for work done. Work done formula, you know. Work done is equal to what? Work done is equal to, you know, work done is equal to F into Q. This formula you have described, you have seen. Okay. Work done is equal to F into displacement, right? Work done is equal to F into D into cos theta. This is a formula, you know. Work done is equal to force applied by displacement mode. Okay. Now, you know, F is equal to what? Force. Force in electric field is equal to energy, right? Q. Okay. Now just put this in this. Okay. In D into cos theta. Okay, now very easy. Now just substitute all these values. What? They have said work done is equal to how much? 10. And they have said energy. No, energy we need to calculate. Energy we need to calculate. And energy is we need to calculate. And charge, how much charge they have taken? 0.5 coulomb. And distance, what they have taken? Distance is 2 meters. 2. And cos theta, cos 60 degree. Cos 60 degree. Very easy. Now just substitute this. How? 10 is equal to E into 0.5 into 2. Just multiply this 2. This multiply this both. What you will get? You will get 1 into cos 60 is equal to 1 by 2. Okay, students, very easy. Now just multiply this by this. Send this to this side. What it will happen? It will be like E is equal to 20. Right? Multiplying this to this. Your answer will be V is equal to. Very easy. Very just simply you calculate this thing. Okay. Now let us move to second question. What your second question is saying? Problems are very easy until you learn it. Okay. Now your second question. Second question. How it will like? A charge is projected into a uniform electric field E. The work done when it's moved a distance V is, okay. A charge is projected to uniform electric field. Uniform electric field. Okay. We are projecting a charge to uniform electric field. This is one case. And work done when it's moved from a distance. Okay. You have projected a charge Q in a uniform electric field. Okay. Suppose you have projected a charge in a uniform electric field. And this charge is moved from this point to this point. Okay. This point, distance is big. Okay. They have just said the work done to move this charge from this point to this point. Now, very easily you can calculate. What? Just simply how? You know, work done is equal to force applied into distance mode, displacement mode. When you applied some force, it moved from A to B. When you applied some force, it moved from A to B distance. Okay, force. Now, just simple. What does force mean in electrostatics? Just simple. Force mean EQ or EQ. Which your option? Your option is A. Very easy. Very easily you solve this problem also. Now let us go to the third problem, which is very interesting. And all of this I have asked you in your theory exams or main exams. Okay. 1 volt is equivalent to 1 volt is equivalent to 1 volt is equivalent to just simple 1 volt is equivalent to joule by coulomb. Okay, 1 volt is equivalent to joules by coulomb. We have discussed this thing. And the fourth question will be like, the work done in bringing a quantity positive charge from infinity distance to a point in a distance x from a positive charge q is W. Then the potential q at the point is what they are saying. Just simple. The work done to bring a charge q from infinity to a point in a charge field. Okay, to a point at a distance x from a positive charge. This is also positive charge. Then the potential at this point is what? This is what we are discussing from 2 classes. What do you mean by potential? The electric potential. Just simple. When you bring a charge from infinity to this point, it will be equal to electric potential. And in this case, electric potential is equal to what? Work done. You all know the definition of electric potential. The work done to bring a charge from a point infinity to a point in electric field is equal to potential difference. So electric potential. This means in this electric potential is equal to work done in bringing a charge from U to this. Very simple. Very simply, your answer will be B. Like we are making a work done for bringing a charge from infinity to a point in electric field. This is called work. And in this case, work is equal to potential, because when you move this to this, it will develop a potential which is equal to work done. Okay, very easily you got to know this also. Now let us see our 5th question. What is it saying to you? Okay. The electric potential at a point in free space due to a charge q coulomb is, okay, due to a charge q coulomb is electric potential at a point in free space due to a charge q coulomb is, okay, charge q coulomb is, okay, this is easy. The electric field at this point is, okay, what they have said, you have taken a charge from point free space to a point in electric field, and at that point from free space to a point in electric field, you have bring this to here. Now they have said the potential at this point is q into 10 to the power of 11 volts. Now they have said to calculate the electric field at this point. What you have to calculate? Electric field at this point. What will be the electric field of this? Just simple. Very easy. How? See, we know this, which is equal to this. But we know the potential formula. Now potential formula क्या होता है? Potential formula is like 1 by 4 pi epsilon naught q divided by r, which is equal to this thing. Now you can simply just cancel this 2 from the both side. Okay. Now we left with the formula. How? Like 1 by 4 pi epsilon naught 1 by r, which is equal to 10 to the power of 11. Okay. If you want only for this formula, you can just write. We are writing just the denominator, like you get this. Okay, very easily you got to know the full formula of this thing. Just simple arrow. We are just sending, this will be 1 always. If we send this to this, what it will happen? 1 by 10 to the power of minus 11. We are just comparing this both sides. Okay, so we got this formula also. Now what we want to calculate? We want to calculate electric field. Electric field in electrostatics can be written as like 1 by 4 pi epsilon naught q by r square. Okay, very easy. Now just multiply and divide by this thing. Why? Because this is square, this is not square, but here all is no square. If we square this both side, we need everything here is square, or else we need to remove this square r square to r. We can't remove this square from here. So simply we make this as square and this square. Simple. Funda khatam. Like 4 pi epsilon naught q divided by 4 pi epsilon naught ka whole square into r square. Okay. Now simply you can write that r square inside 4 pi epsilon naught r square. Now just take this value to put here, like 4 pi epsilon naught q divided by 10 to the power of 11 whole square. Now your answer will be like 4 pi epsilon naught q 10 to the power of 22. What you got answer? Is your answer is right? Yes, your answer is right. Okay, just simple. You multiplied by this, what would happen? It will be like 10 to the power of 22. Remember one thing, we are multiplying this 2 with this, we are not squaring. Okay, so it will be like 10 to the power minus 22. When you go up, it will become like this formula. Very easy you solve this. Now let us see another question. धीरे धीरे सनम कैसे क्या हो गए हम खुदा Dear student, what is your seventh problem saying? An electric field 10 to the power minus 3 microcoulomb is placed at the origin 0 into 0 on xy coordinate system. Okay, 2 points A and B are situated at root 2 and 2, 0 respectively. The potential difference between A and B. Okay, very simple. Just easy, like an electric field 10 to the power of minus 3 microcoulomb is placed at 0 into 0. ये क्या है? ये 0 into 0. Electric field इस point पर इतना electric charge. We have placed an electric charge, like we have placed an electric charge at this point. Like this is this is x-axis, y-axis, like x-axis, y-axis. We have placed an electric charge at this 0, 0. Now what you have to coordinate x, y coordinate. We written x, y coordinate very easily. Are situated at, okay. After this, A, B are situated at root 2 and 2, 0. Okay, root 2. Oh, okay. Just simple. Now take the value A and B. So first of all, we will take the value of A. They have said the value of A will be like root 2. 2 will come 1, 2, 3, 4. 1, 2. So it will be like at this point root 2. Okay, what is the value of this? This will be like A, root 2. But 2, 0. This will be B. Got 2, 0. Okay, this is all the thing. We have taken the first charge at 0, 2. First of all, we move this charge to here. Then we move this charge to here. And we need to calculate the potential difference. Potential difference at this point, we calculate and just simply ended this one. Okay. How? First of all, what happened? We calculate the potential at this point and later potential at this point. Okay, come on, let's calculate it. Okay, potential. What is our formula of potential? You all know potential means 1 by 4 pi epsilon naught q by r square. R. Okay. For main thing, the distance between these two is 2. Like 2. Distance between this is 2. Okay. Now, what it will be like? Distance are same. Okay. Before that, we calculate distance. Okay. Sorry. Now we'll calculate first distance. This r distance we calculate, because we need r in this. We know the charge value, but we don't know distance value. So we calculate for distance. Let us calculate distance for this. So distance for this you can calculate by, like, just simply root 2I plus root 2j. If you just take the magnitude of this, what will happen? It will be like magnitude 2 plus 2 is equal to what happened? Magnitude 4, right? Total answer. When you put this into this, it will be like V1 is equal to Q by 4 pi epsilon naught 1 by 2. Very easy. Now let us similarly find for this. So when you find for this, R2 is equal to like what? Simply 2I. When you take the magnitude also, it will be like 2 is equal to 2. It will be like 2 only. So when you write this also, this in this, it will become like 1 by 4 pi epsilon naught Q by 2. Sorry, Q by 2. Now we know the value of Q. What will be the value of Q? In this place, value of Q is equal to 10 to the power of minus 3. Okay, student. Here also the value of that will be 10 to the power of minus 3. Okay. Now what they have said to calculate potential difference. Potential difference means the potential at final, potential at initial. Okay, potential at final minus potential at initial. What is the potential at final? Potential at final. There is potential at initial. There is like potential at final and potential at initial. And now just you can subtract the h. What your answer will be like? 0. Your answer is 0. See, your answer is 0. Write down. Okay. Now let us continue by solving problem 8. Okay. Now, what the problem is saying? What is the electric potential at distance of 9 cm from 3 nanocoulomb? Okay, this is very simple problem. This kind of problem is like chutki bajake, within a 10 seconds problem. They have said just distance. So they have said like potential, electric potential at distance 9 cm. Okay. Okay. What you need to calculate? Electric potential is equal to 1 by 4 pi epsilon naught, and charge is equal to R distance. Okay, very easy. Now charge they have given, how much charge they have given? Charge will be like 3 nanocoulomb, or 3 into 10 to the power of minus 9 coulomb. Okay. And distance they are given like distance 9 centimeter. 9 centimeter means you can write 9 into 10 to the power of 2 minus 2 meter. How you can write? You can write this as 0.09 meter. Okay, very simple. Or else you simply write this also. It will okay. You can write this also, this also. It's up to your convenient. But always remember this. Okay. Now just substitute this value, and you know the value of this is 9 into 10 to the power of 9. Okay. Now when you substitute this all values in that, what will be like? Into 9 into 10 to the power of 9, and charge of Q value is 3 into 10 to the power of minus 9 divided by this one is 9 into 10 to the power of minus 2. Okay, very easy, very simple. Now we just multiply like this one by this thing. Okay, and now just simple. This is this thing. Okay, now what you get finally? You got this. Just send this upward. It will be like 3 into 10 to the power of 2. You can write this as 300. You got your answer. Your answer is 300 volt. Okay, very easily you solve this problem also. Now let us see similarly another problem. A, as shown in the figure, okay, below, as shown in the figure below, a charge plus 2 coulomb is situated at the origin and another charge plus 5 coulomb is on the x-axis at a point A. The charge from point A is brought to point B in a y-axis. The work done is, okay, what they have said, they have just said like take two charges. You broad-minded, you very hot boy, take two charges. One charges at initial, one charger at O point, what, 2 coulomb, and another charge take in x-axis here somewhere 5 coulomb. Okay. After some time, send this to y-axis, which is also 5 coulomb. Similarly, these are the same charge we are just sending to this. Now they are set to calculate work done. I think you have got your answer now itself. Because how, like, the distance will remain same when it go to this side, and charge also remains same. What will be answer? When final divided by final minus initial, 0 it will answer. But also we do for your convenient. How it will be write work done? Work done is equal to final potential. So final potential minus initial potential. Now just final potential is equal to final potential. First of all, initial potential. Okay, initial potential. What is the initial potential? This is A. At this point, initial potential will be like 1 by 4 pi epsilon naught, and charge is 5 because of this also. 2 into 5 divided by distance will be like r. Or you can take distance as anything. You can take r. Okay, r distance. R you take 5 centimeter because this is a distance 5. Okay, r, and final also it will be like same 4 pi epsilon naught 2 into 5 into r, because this also r, this also r, because because this is 2, this is 5, the same distance. It will like just like this is at this point plus 2 coulomb, at this point plus 5 coulomb. Distance is same, just this time we are doing. Now distance change, no, distance also same, that's why both are same. Now just substitute this one, this, what it will be like 1 by 4 pi epsilon naught for the 10 minus r into 1 by 4 pi epsilon naught 10 minus r. Answer 0. 0, 0, 0. Now let us see the next question, which is very interesting. Okay. Come on. Come on, come on, baby. Come on, come on, come on. Come on, come on. Okay. So, next question. The charge Q is placed at the origin of XY axis, as shown in the figure. The work done in taking a charge Q from A to B along a straight line AB is, okay, they are given a figure like this, what, 0 at A comma B, and at this point B comma B. Okay, you just now calculate in the past problem potential, but it take very lengthy problem, length. So they are just simply asked to write a formula of this, right? Why a formula लिख दो, खत्म कर दो. What? A charge Q is placed at the origin. A charge Q is placed at the origin of XY axis is shown in the figure. The work done of charge from A to B. This charge is moving from here, and from this point it's moving from this point B, and they are set to calculate potential. Okay. Okay. Now charge Q be straight line. So, just simple. Now calculate potential energy at this point and potential energy at that point. Very easy. So, what it will be like? Potential energy. Like potential energy at this point, it will be like 1 by 4 pi epsilon naught Q. Only one charge Q divided by what is the distance? A. You have said the distance A and distance B. Similarly, for this 1 by 4 pi epsilon naught Q divided by B. Very easy. Okay. Now just we know potential formula. Potential is equal to mean potential is equal to potential A minus potential V minus potential A. Final potential minus initial potential. Now what is the final potential? Final potential 1 by 4 pi epsilon naught Q by B minus 1 by 4 pi epsilon naught Q by A. Now just take the common 1 by 4 pi epsilon naught Q 1 by B minus 1 by A. Now multiplying this inner product 4 pi epsilon naught A minus B divided by A. Very simple. Just taking common A, B, cross multiplication. Okay, very easily you solve this also. What is your answer? Your answer is this. Okay. Now this is for one charge. If you take two charges, if this, suppose imagine here is one charge and here is two charge, then what it will happen? Just simple. This charge is Q, this charge become Q here. Simple, very simple. This is for one charge, this is for two charges in your exams. Now let us see another problem. Another last problem in this. Okay. So what is the last problem? A charge Q is placed at the origin. The electric potential due to this charge at a given point in space is V. The work done by an external force in bringing a charge Q from infinity to a point in charge is. This is also just simple. They have said a charge Q is placed in the origin. This is a charge Q is placed in the origin and it has some electric field origin. Okay. The charge is due to a charge point. Okay. The work done by external force is bringing another charge Q from infinity to a point in charge. We are bringing another charge Q from infinity to a point in charge. Now they said to calculate what? They said to know. To calculate what they have said, the work done by to calculate work done. To calculate work done. The work done of taking a charge from infinity to a point in this electric field. How you can calculate? Very simply, you know that. You know, this is a formula. It is normal formula. It's a basic formula. Work done is equal to this one. But also, you can solve this. How? It will be like no. So, what it says, the work done is equal to potential into charge. The work done is the amount of potential energy required to bring a charge from infinity to a point in field. This is a very easy problem and this is a very fundamental problem. The definition you need to remember, but also it's very tricky. Not tricky, it's very easy, very fully easy, dead easy. So these are the problems you can expect in your IIT, NEET or JEE or CET also. If it come, it's very good for it. Or they will ask a problem similar to this kind of concepts. So I hope you like this video. If you have seen up to that, very thank you and salute.